Sample size is not a formality, it's a scientific justification. Every number in your research tells a story, but the right number of participants decides whether that story is trusted or ignored. Too small? Your results collapse. Too big? You waste time, money, and effort. So today, in just few minutes, we'll break down sample size calculation not with heavy math, but with clear logic. Let's make statistics make sense. Imagine reading a medical study based on just 10 people. Would you trust the conclusion? Probably not. That's exactly how journal editors think. An underpowered study, meaning too small a sample, produces unstable and unreliable conclusions. One small change in data can flip the result completely. Editors look at sample size because it answers one big question. Was this study planned scientifically or casually? A proper sample size shows without it, your study looks like an opinion, not evidence. That's why journals reject papers not for poor results, but for poor planning. And sample size is planning in numbers. When calculating sample size, you must mention 4 things clearly. First, prevalence or effect size. How common is the condition? Or how big a difference do I expect? Allowable error, also called margin of error. This answers, how wrong can I afford to be? Is plus or minus 5% okay? Or do you need plus or minus 2% precision? Smaller error is equal to larger sample needed. Formula used. You must state which mathematical formula or statistical method you used for calculation. Not mentioning the formula is like saying I cooked food but not telling the recipe. Turn a guess into a justified number. Now let's talk about the mistakes that destroy credibility. First, convenience sampling. This means selecting people just because they are available. Students in your class, patients who came that day, friends and relatives. Easy? Yes. Scientific? Second, no reference. Some papers say, we took 100 samples. But why 100? Based on what? From which source? Without reference or logic, 100 is just a lucky number. Third, wrong assumptions. If your prevalence is guessed incorrectly, your entire calculation collapses. If your error margin is unrealistic, your sample becomes misleading. Wrong input is equal to wrong output. These errors don't just weaken studies, they make them rejectable. Statistics doesn't forgive shortcuts. Sample size is not just a number. It's a reflection of planning. It shows you thought ahead. You understood uncertainty. You respected scientific standards. Good research doesn't start with data. It starts with design. And design begins with, how many do I need to study to say something meaningful? Because in science, more important than what you found is how you found it. Sample size shows planning, not just numbers.